Okay, now it took you guys a while to get this done. It's taken you over a lesson almost, but I can understand that you're doing your SAC and looking over your SACs and things like that. But let's time it. The video's been going for a short amount of time. Let's see how long we can get this done in. All right? I would expect this sort of thing to maybe be 10 minutes. Let's go for it then. 2z minus 4w is 2, 3 minus 4i. Minus 4, 2 plus 5i. And I'm just going to equate, that's going to be 6 minus 6. So the real part is going to be, 6 minus 8. So the real part's going to be minus 2. Just collecting real and imaginary. Minus 8, minus 20. Is it minus 28i? Yes. Okay, good. That's how I would set it out. Z times W. Now be careful because we know that we need to write it out. 3 minus 4i times 2 plus 5i. Okay, you do need to realise, and if I pause the video just for a second, resume. Okay, so what you need to realise is that I squared is negative 1. So when we're doing this, we always can simplify that because that is a real number. Negative 1 times... like say if I had 5i squared, is it real or imaginary? Real. It's real. Okay, so what I've got is I've got 6 plus 15i minus 8i minus 20i squared, which of course, collating those, 6 and negative 20i squared is actually, so 6 negative 28. Oh, sorry. No, oops. That's what happens when I do it on this thing. I don't make mistakes when I do it on paper, though. I don't know what's going on with me. 6 plus 15i minus 8i minus 20i squared. Well, we just discussed that. What does that equal to? Plus 20. Thank you. Good. So the answer, therefore, is 26 plus 7i. Can I get a show of hands of students that got that one correct? So that should be all of you. Thank you. Okay, I'm going to pause the video now and make some room, and we're going to go through part C. Okay, we're back in the room. Okay, Z, W over Z. Well, you could do this a few ways, and you should have learnt in Gen A last year, 2 plus 5i over 3 minus 4i. Now, whenever simplifying this, what we have to do is we have to multiply by the conjugate. Now, I'm going to pause the video and have a little discussion with you guys what the conjugate back in the room. Okay, so you can see there that what I've done is I've multiplied by the conjugate, and that's whenever you have two complex numbers, WZ or Z over W, then that's the best way, the best method to actually get it. I'll show you in the calculator later, but let's do it. 2 times 3 is 6. 2 times 4i is 8i plus 15i plus 20i squared. That's what I get on the top. Okay, that is equal to, therefore, now we instantly know that if I multiply 3 minus 4i by its conjugate, is it going to be real? Is it going to... Yes, it is, because it's a difference of 2 squares almost, isn't it? Okay, so what we're going to be saying is 3 times 3 is 9, minus 4i times 3 is minus 12i. The imaginary part's going to disappear. And it always is the case. If you get that when you're trying to do that and you've still got an imaginary part, then you've done it wrong, haven't you? So these two things have to be, well, that's why it is the conjugate. So on the bottom, we know it's going to be 9 minus 16i squared, which is going to be 25, yeah? 9 plus 16 is 25. So therefore, I'm going to now collect. Now be careful, I squared's negative 1, so that's going to be negative 20 plus 6, which is negative 14. I've got negative 14 plus 23i, plus 23i over 25. Can I get a show of hands of students that got that correct? Thank you very much. Okay, now over here, this one over here, pretty straightforward. It's the same thing, except this time we've got Z bar. So what we need to do is we need to go Z bar is 3 plus 4i. And then that is divided by W bar, which is 2 minus 5i. And I'm doing the same thing. I'm multiplying by 3 minus 4i over 3 minus... no, we don't. No, we don't. We do not do that. Okay, we multiply it by what? 2 plus 5i. I swear to God, it's so much harder when you've got to do this on this stupid computer. All right? But I swear to you, I don't make this many mistakes. I hope I don't anyway. All right, let's do that and let's see what we get. Okie dokie, we've got 6. We've got 6 plus 8i plus 15i, which is plus 23i, plus 20i squared, which is minus 20, over, we know that's going to be 4. We've got that as minus 25i squared, which is plus 25. So, therefore, my answer should be negative 14 plus 23i on 29. Do we agree with that? Awesome. Okay, now what about if I'm just going to pause the video for a second and have a little discussion about this guy? Okay, so this time what we've got is z conjugate times w conjugate, which we need to know as that is 3 plus 4i times 2 minus 5i, and then when I expand that out, that's going to give me 6. 8i minus 15i is minus 7i, minus 20i squared is plus 20, so the answer should be 26 minus 7i. Do I get a hallelujah, amen for that? Yes? Good. Hallelujah, amen. All right, 3 minus 4i squared. The next one, 3 minus 4i squared plus 2 plus 5i squared. All right, let's not do the whole year 8, 9 thing where students are sort of saying that 3 minus 4i squared only has 2 terms. That's not, you shouldn't be in specialist maths if you're doing that. But let's go ahead and do that. I'm just going to do that in my head. Minus 4i times 3 is minus 12i, so that's going to be minus 24i, and then that's going to be 9 and minus 6, 16i squared. 9 minus 6, yes, 9 minus 16 minus 24i. That's what that one should give me, just because I've worked it out in my head. But if you want to do it, do some extra working, go for it. Plus 4 minus 25, because 25i squared is negative 25, plus 10i plus 20i. Am I missing anything, or is that okay? Yeah, I think that's right, isn't it? Okay, so therefore I've got, let's go, we've got 13, so 13 minus 41 is minus 28, minus 28 minus 4i, is that correct? Yep. Yes, good, all right. And let's do, so we've done that one. This time, now this one looks confusing, but let's just write it. The real of z bar. Now what is z bar? Z bar is equal to 3 plus 4i. So the real part, I want you to know this, that the real part is 3. Some people thought, though, that the imaginary part here is 4i. It's not. The imaginary part, the real is equal to 3, and the imaginary is equal to 4. Thank you. Now, so if I'm asked for the reals of z bar, then the real of z bar is just 3. Let's have a look at the imaginary of z minus 2 all squared. Well, let's do it. Z minus 2 all squared is equal to 3 minus 4i minus 2. So it's actually 1 minus 4i squared, which we know is going to be 1 minus 8i plus 16i squared. That's negative, so that's going to be negative 16. So we're looking at negative 15 minus 8i. Now, we're multiplying the imaginary part of this. The imaginary part of this is what? Someone shout it out. Negative 8. So therefore the answer is the real of z bar, which is 3. 3 times negative 8, which is equal to negative 24. Can I get a show of hands for students that got that? Good. Good. Okay. Now, I want to pause this video because I want to talk about what polar form is. Okay, I'm going to review there. I've just started the video again. Shh. Okay, now it's saying here, write z equals 2 cis minus 5 pi on 6 in Cartesian form. It's what I... Listen to me and listen to me carefully. Always draw an Argand diagram when you have to answer this question, because what is it going to tell us? It's going to tell us what quadrant it's in. It's going to tell us whether the real part is positive or negative. It's going to tell us whether the imaginary part is positive or negative. Can someone tell me what is the real and the imaginary in terms of its sign of 2 cis of minus 5 pi on 6? It is negative. Okay? Thank you. It is negative. All right? So, instantly, you know that in Cartesian form, I've got negative something, negative something. What am I missing? I. And then this is the imaginary part and this is the real part. Now, as it turns out, we need to... Now, you can do with this the long way if you like, but what 2 cis of negative 5 pi on 6, polar form, this is in polar form. Now, all polar form what is it's a point which is a distance from the pole. In other words, the modulus is, in this case, 2, and it has an argument, which basically means the argument of z is equal to what? Negative 5 pi on 6. So, what a lot of students do is they think that this is like a vector. No, it's not. It's a point which is in relationship to a pole, and it gives it an angle, and that's essentially the same thing. So what we're saying then is 2 cis of minus 5 pi on 6 is the same as 2 cos of minus 5 pi on 6 plus 2I sine of minus 5 pi on 6. Now, the thing is, I've written up here, and I should know what's cos of pi on 6 and sine of pi on 6. They're the reference angles. And you guys that have done year 12 methods, you've done this sort of stuff over and over again. All right, but even if you've just done year 11 methods, you should realise that those reference angles. So now we've agreed that, because it's the third quadrant, we know that cos and sine are both negative. So we use those, but we referred back to the first quadrant and get our exact values. So 2 cos of minus 5 pi on 6 is negative root 3 on 2 times 2 plus 2 times negative a half. What's missing? I, because it's cis is cos theta plus I sine theta. Okay, are we starting to remember this now? Some of this stuff. Okay, good. Minus root 3 minus I. Can I get a show of hands, the students that got that correct? Can I get a show of hands, the students that didn't get it correct? Be honest. Come on, someone. Okay, thank you. And it was just a sign error, wasn't it? Okay, sign errors. Now, let me just pause that video and I'm going to go back in the room. Okay, so with this one, the reason why in this question we're in polar form is because it is, please, this is the most important thing. I'm going to get my highlighter out. Polar form just makes life easier, okay? It makes life easier. Okay, because when we have to do things like multiply two complex numbers together, we can find their angles instantly in polar form. We can't do that in Cartesian. A lot of the time we do stuff in Cartesian, we convert to polar. Trust me, polar form is better. Please remember that. Now, ZW. Now, we agreed that ZW is whatever in Cartesian form, but we have to find W in polar form. So let's do that, but of course we've got to draw an Argand diagram first. And we've got our real axis and our imaginary axis, and our real is positive and our imaginary is negative. So we are in which quadrant? Quadrant 4. If I go 2 across and 2 root 3 down, let's just do this for the time being. Okay, I have a point. I don't have a line, I have a point which is a certain angle from the pole. All right, now I haven't drawn to scale. We have to find out what that angle is first. Now, for starters, so we know that this point is a distance from the pole, which is called what? What do we call that? Modulus. Now, this is W. So that's modulus of W. Oops, oh, that's the worst W I've ever done. Okay, modulus of W. Have you seen that before, yes? Yep. Now, what is the modulus of W equal? Isn't it just using Pythag? We'll just go 2 squared plus negative 2 on root 3 squared. Okay, which 2 root 3. Oh, gee, thanks for letting me know that. That's okay. Okay, thank you, Yang. So let's just forget about the sign. That's 2 root 3, yes? Okay, so what I do is I go ahead in here and I change that to a 2 root 3 squared. Forget about the negative for now because that's going to just... All right, so we've got 4, 12. That's going to be the square root of 16, which is 4. Did we get that? Okay, so what this is this is a line which is 4, and what's the reference angle? What's this angle in here? What is it? Pi on? Yes, thank you. So our reference angle, now we've been through this, SOHCAHTOA, tan theta. Tan theta is equal to opposite over adjacent, which is 2 root 3 over 2, but you've got to consider that that's the negative of that, which is negative root 3. We're looking at the reference angle. The reference angle is pi on 3, isn't it? So therefore, theta is equal to pi on 3, but in terms of this, so therefore, this in polar form, we know, we've drawn our Argand diagram, we know it's in that quadrant, we therefore say that it's 4 cis of negative pi on 3. Can I get a show of hands, those students that got that one correct? Awesome. Now, the reason why we converted into polar is so going to be very obvious here. ZW, if I go ahead in Cartesian, then it's going to take a lot longer. However, ZW in polar form is equal to, and I'll better write it out, 2 cis of minus 5 pi on 6 times 4 cis of minus pi on 3. Now, what you need to do is, if we're multiplying two complex numbers together, you need to remember from last year that we multiply the arguments. Is that the argument? No, modulus. We multiply the modulus, 8, and we add. Now, be careful though. Minus 5 pi on 6 plus minus pi on 3. Let's get that. Let's do our fractions. This is where students make mistakes. Minus pi on 3 is minus 2 pi on 6. We've got 8 cis of negative 7 pi on 6. The problem is that you should have recalled from last year. Now, I can't vouch for exactly how deeply you went into complex numbers, but I'm going to make the assumption that you should have been told that, and it's on your formula sheet, your specialist maths formula sheet, that the arg of z is in between pi to negative pi. It's not inclusive of negative pi. This is one of the most important things you need to know. Can I get a show of hands, those students that remember that? Okay, so can I ask you, is this argument within these bounds? No. No. So what I have to do, I have to add 2 pi. So adding 12 pi on 6 means that to be within those bounds, ZW has to equal 8 cis of 5 pi on 6. And that is your answer. Can I get a show of hands of students that got that one correct? Only 5 students out of 5 or 6 students out of a class of 23. I knew that would be the honest mistake because we need to recall that, and it was a long time ago. Okay, if I get my highlighter out, ladies and gentlemen, that means that it's an important thing and it's something that students don't consider a lot. So there you go. I've got my highlighter out. What else have I got my highlighter out for? What does polar form make it? Easier. pretty much all the time, polar form, but you will work out some cases where Cartesian is better. I'm going to pause the video there because how long have we done? We've gone again, I'm going to be really quick. Okay, now for this one, W over Z is equal to 2 cis, we've got, what was that? That was 4 cis of minus pi on 3 over 2 cis of minus 5 pi on 6. And you needed to remember from last year that 4 over 2 is 2, and we have to subtract the arguments in this case. So, subtracting the argument, minus pi on 3 minus negative 5 pi on 6 is equal to 2 cis of minus pi on 3 plus 5 pi on 6 minus 2 pi on 6, which is equal to 3 pi on 6, which is 2 cis of 3 pi on... Is it pi on 2? Yeah. Yes? Hands up. Luke, you got that? Yeah. Okay, good. Good. Now, if I look at z cubed, let's have a look. Now, z cubed, did you look at De Moivre's theorem last year? You should have. You should have. I'm not sure. Okay, cis of minus 5 pi on 6. Now, that is that cubed. Now, good old De Moivre said that... De Moivre, I think it is. All right, 2 cubed is 8. And what we do is that we multiply the argument by the power. Minus 5 pi on 6 times 3. Okay, which now that's going to be equal to 8 cis of minus 15 pi on 6, which is well outside of the range. So what I have to do is I have to get it back in it. All right, I'm going to add 12 pi on 6, which is what? 2 pi, isn't it? Which is going to give me negative 3 pi on 6, negative pi on 2. 8 cis of negative pi on 2. Now, that 8 cis of negative pi on 2 is just z cubed. Okay? Now, guys, if the bell goes, I just want you to stop there for a second. Okay? And just don't go rushing off. Yes?
I just want to say with the part before, sorry.
Yeah.
So, with the pi on 2, could you just simplify that to just GI?
Yes, absolutely. I've left it in polar, but you guys know how to convert to Cartesian now. But yes, you're right. 8 cis of minus pi on 2. Now, let's go ahead and we've got 8 cis of minus pi on 2. Now, the square root of w is equal to what? We've got w is equal to 4 cis minus pi on 3. So, the square root of w is equal to 4 cis of minus pi on 3 to the power of a half. The square root of 4 is 2, so that's going to be 2 cis of a half, which is minus pi on 6. Do we agree with that? Yeah. Okay, so therefore, just hold on a sec, don't go anywhere. That is equal to 8 cis of minus pi on 2 over 2 cis of minus pi on 6, which is equal to 4 cis of minus pi on 2 minus plus pi on 6 minus pi on 2 plus pi on 6 is equal to, that's going to be minus 3 pi on 6 plus pi on 6 minus 2 pi on 6 minus pi on 3. Can I get a show of hands of students that got that one correct? Good, and that's a number of you that didn't. Now, the rest of them are all pretty much using the same things. I'm going to stop there, and this is going to be the first video in the series.